In this lecture, I'll be discussing about input-output write machine cycle. So in an input-output write machine cycle, the CPU sends data to an input-output port or input-output device from the accumulator. So how it does? The microprocessor sends the 16-bit address first to the input-output port through the address bus and address data bus. Now, since the address data bus is working in time multiplex mode, so it needs a latch for demultiplexing. So once demultiplexing of address data bus occurs and the address data bus gets free for carrying the data, microprocessor loads the data from the accumulator into the data bus. Now once the address reaches the input output port, the data that is loaded on the data bus travels to the input output device and gets stored there. So this is how the input output write operation is being performed by the microprocessor. Now let's see the timing diagram. So an input output write cycle is exactly similar to a memory write cycle. In case of input output write cycle, IO/M bar goes high, indicating that the address sent out by the microprocessor is for input output device or input output port. The address of an input output port or device is duplicated on both A8 to A15 and AD0 to AD7 buses. The out instruction is used for input output write. Now, this is how the input output write timing diagram, the same thing, just two differences, that is in the IO/M bar and the data, that is the address, gets duplicated in both A and AD buses. And the whole procedure remains same. So now let's see an example. Let's take an instruction STA. You might have come across this instruction while going through the experiments of microprocessor lab. That is STA. There is some data. So here I have written the data like 526A, that is written in hexadecimal format. So in hexadecimal, whenever I will be writing any data in hexadecimal format, I will be using H here. So STA 52606AH, what it does, it stores the content of accumulator into the address mentioned in this instruction. So let's see how many machine cycles are needed for this instruction. So the machine codes for STA 526A are 32H is the opcode for this instruction STA data. 32H is the opcode for this instruction, then lower byte of the instruction and then higher byte of the address mentioned in the instruction. Again I am repeating, first is the opcode, then lower byte of the address, then higher byte of the address. In a similar way only this instruction will get stored in the memory. How? First the opcode of the instruction will get stored in the memory location, then the next memory location will be occupied by the lower byte of the address, and the next memory location will be occupied by the higher byte of the address mentioned in the instruction. So how many machine cycles will be needed for the execution of this instruction? First machine cycle for fetching the opcode from the memory, that is opcode fetch machine cycle. So once the opcode is being fetched by the machine cycle and after decoding, microprocessor will get to know that it needs to store the content of the accumulator into some memory location, but it does not have the address there because the address is stored in the memory. So the next two machine cycles will be used for memory read, that is for reading the lower byte of the address and for reading the higher byte of the address. So now three machine cycles have been used. First for opcode fetch machine cycle, second for reading the lower byte of the address, and third for reading the higher byte of the address. Now what will happen after getting the address? What microprocessor will get to know? Now it needs to store the content of the accumulator to that address. So the last machine cycle will be used for writing purpose, that is memory write machine cycle will be performed, and that too for writing the content of accumulator into the address, into the mentioned address. So here these are the four machine cycles. First is opcode fetch, second one is memory read, that is reading the lower byte of the address, then again memory read, that is reading the higher byte of the address mentioned in the instruction, and the third one is memory writing, memory write, that is writing the content of the accumulator into the mentioned address. And these are the T states. Opcode fetch will require 4 T states, memory read will require 3 T states, memory read will require 3 T states, and memory write will require 3 T states. So this is the whole timing diagram for the instruction STA data. This is the opcode fetch timing diagram, memory read timing diagram, memory read timing diagram, and memory write timing diagram. So whenever if in exam I give you any instruction and I tell you to make the timing diagram for that instruction, what you need to do is that first you need how many machine cycles are needed for the complete execution of that instruction. So in this instruction, like there are 4 machine cycles. Now next thing what you will do, since there are 4 machine cycles, accordingly I have told you, I have shown the timing diagram of each and every machine cycle, like opcode fetch machine cycle, memory read machine cycle, memory write machine cycle, input output read machine cycle, or input output write machine cycle. So what you will do, you will first find the number of machine cycles that the instruction needs, and then accordingly you will make the timing diagram. So everything will remain same. These all the necessary steps will remain same as I have shown you previously. Like for opcode fetch, everything is same. For memory read, everything is same as I have shown you in my previous slides. And for memory write also, everything is same as I have shown you in my previous slides. So up to this point, I'm ending this class here. Hope you're understanding the topic. For any doubts, do comment on our WhatsApp group. I'll try to reply all your doubts in our Google Meet session. Thank you.